Hello everybody and welcome to Pankaj's Echelon tutorials, and today we are going to start with the IGCSE curriculum, and the subject that we have chosen is chemistry. Okay, and the name of the chapter is electrochemistry. This is, I suppose, chapter number 5. Okay, this is chapter number 5, and the book that I am referring to is the Coursebook. Okay, the one second, it's a Hodder's publication. Okay, Hodder's Coursebook in chemistry, and this is the fourth edition. Okay, the fourth edition, the very latest one. Okay, so this is the book I am referring to. Fine. So today's topic, as you can see on your screen, it's electrochemistry, and let us get started. So first of all, let us try to understand what this word electrochemistry actually means. Okay, now you must know what is electricity. Okay, and today you are introduced with a new word, that is electrochemistry. So is there any connection between the two, electricity and electrochemistry? Let us try to find out. Okay, so we know that electricity is a result of moving charges. Yes, we all know that whenever the charges are moving, then the electricity is resultant. That is known as current electricity. Well, we also know that metals contain lots of free electrons to help conducting electricity, and hence they are known as good conductors of electricity. Fine, that is also very true. In chemistry, what happens, you have many ionic compounds, okay, which can be split into ions, that is cations and anions, and these ions are having charge on them. Okay, any ions will have charge on them, either positive or negative. So when the charges move, that is when the ions move, electricity is again resulted, because electricity is nothing but the movement of the charges from here and there. Okay, so ions, when they are moving, and because ions are having charge on them, so moving ions can also result in electricity. So that is the connection between electricity and electrochemistry. Okay, so can you see this in red? I have given you the real this thing meaning of electrochemistry. So electrochemistry is the relationship between the chemical reaction and the electricity. Now this is the precise meaning and the definition of electrochemistry. If you want, you can say that electrochemistry is a relationship between the chemical reaction and the electricity. Okay, now some chemical reactions can generate electricity. Okay, and electricity can make some chemical reactions take place. Okay, so both the way it works, some chemical reactions are such that when the reaction is going on, it can generate electricity, and the reverse is also true, that is electricity can make some chemical reactions take place, otherwise it would have not been possible for that reaction to take place. Okay, so both the things are seen. Okay, so there are certain chemical reactions which are helpful in generating electricity, and there are certain chemical reactions which cannot happen at all without electricity. So electricity and chemical reaction has some sort of connection between them. Electricity is due to moving charges, and in chemistry, in redox reactions, that is reduction oxidation reactions, electrons move between the atoms. Okay, so you know that in chemistry, in redox reactions, the electrons, they move from one atom to another atom. So when these electrons are moving, obviously there will be electricity resulting out of it. So there is some relationship between chemical reactions and electricity, that is for sure. So let us carry on from here. These ionic compounds, okay, which can help in conducting electricity, particularly in molten state or in aqueous solutions, are called as electrolytes. So what are these electrolytes? Electrolytes are certain chemical substances, and particularly they should be ionic compound. Okay, that's very important, because ionic compounds can only give ions. Okay, so ionic compounds will give you ions, and these ions, when they are moving, it will give you electricity, or it will help in electricity. Okay, so this is something which is known as electrolysis. So if somebody asks you the definition of electrolysis, then this is the definition. Okay, electrolyte is that particular chemical substance, that ionic compound, okay, which will ionize, and it will help in conducting electricity. That substance is known as electrolyte, and the process of getting electricity from the chemical reaction is nothing but electrolysis. So let us try to understand the process of electrolysis. So here you have the process of electrolysis. Electrolysis as a process is a process and its application. So we are going to study this point, electrolysis as a process and what are its applications, right? So this chapter, now we are beginning to start with the very first term, that is electrolysis. Now let us get started from here. This is very important. Okay, electrolysis. Electrolysis is a process of decomposition of an ionic compound in molten state or in aqueous solution state into its corresponding ions by the passage of electric current. So this is precisely from year to year is the definition of electrolysis. So what is electrolysis? It is a process of decomposition of an ionic compound which is known as electrolytes, and this electrolyte should be either in molten state or it should be in aqueous solution state, and this electrolyte will be decomposed into its corresponding ions, okay, that is cations and anions, and this will be possible by passing current, electric current through it, and this entire process is termed as electrolysis. Fine. So electrolysis has application in manufacturing industry and in other related industry like electroplating, etc. So this electrolysis process is used in manufacturing industry for manufacturing so many substances, chemical substances. For example, aluminum, in the manufacturing of aluminum, this electrolysis is playing a very important role. Then this electrolysis is also used in electroplating. If you want to apply a layer of say gold on some other metal, okay, that is known as electroplating. Or if you want to apply a layer of say silver on some other metal, okay, that is known as electroplating. So electroplating is possible with the help of this electrolysis. So these are some of the applications which we will be doing in detail later on. Now coming to terminology of electrolysis. Now what are the terms which are involved in electrolysis? So now that you know what is electrolysis, it's a process, okay, in which electric current is passed through an electrolyte, and the electrolyte is decomposed into corresponding anions and cations, and these anions and cations, they carry charges and they move inside the liquid, and that is how the current is also generated, okay, electricity is also produced, okay. And actually see, this electrolysis is a process of decomposing that electrolyte. It's not used for producing electricity, okay, but we know that the flowing of current is nothing but electricity. So we are using this in a reverse way. So electrolysis necessarily means that making use of electric current, we are going to ionize, or we are going to decompose the ionic compound. Okay, now what way it is going to help us, that we are going to see. Okay, now what are the terms and terminology connected to electrolysis? So first is something called electrolytes and non-electrolytes. Now as I told you in the beginning only, what are electrolytes? So electrolytes are nothing but any chemical substance that can be decomposed into ions by passing current through it, okay, are called electrolytes. And those which cannot be decomposed, okay, and by passing current through it, are called as non-electrolytes, okay. So there are electrolytes, there are non-electrolytes. There's an alternate definition, slightly different. Chemical substances that conduct electricity in molten state or in aqueous solution are called electrolytes, and those which do not conduct electricity in molten state or in aqueous solution are known as non-electrolytes. So this is also a good definition, right? So electrolytes and non-electrolytes are clear to you. Now coming to next term, that is electrodes. Now what are electrodes? Now these electrodes are uh, in general they are known as electrodes, but in particular there are two types of electrodes, anode and the cathode. Okay, so what are these electrodes? Let us talk about that. Electrodes are rods, okay, made up of unreactive metal or non-metals like carbon or graphite. So basically these electrodes are rod-like structure, okay. These rods are inserted into the electrolyte, into the molten electrolyte, and these rods, they are made up of some unreactive metal. Those are made up of metals which are not taking part, or which are not reacting with the ions of the electrolyte. Okay, so it should be unreactive metal, or it should be a non-metal like a carbon or a graphite. Okay, so that are electrodes, and there are two types of electrodes, anode and cathode. Now this anode is an electrode which is connected to the positive terminal of the power supply, that is DC power supply. We have to use a DC power supply, that's important. Okay, DC supply. Now the electrode which is connected to the positive terminal, okay, of the power supply is known as an anode, and the one which is connected to the negative terminal of the power supply is known as the cathode. So anode and cathode are the two electrodes connected to the positive and the negative terminals respectively. Now coming to cations and anions. Now what are cations and what are anions? As I told you, in electrolysis what happens is, on passing the current, okay, to the electrolyte is going to be decomposed, and it will decompose into two types of ions, the positive ion and the negative ion. Basically any ionic compound is made up of, ionic compounds, they are made up of two types of ions. Okay, they are made up of two types of ions, cations and anions. Okay, cations are the ones which are having positive charge, and anions are the one which are having negative charge, isn't it? So cations and anions are the two components of any ionic compound. So when this ionic compound is decomposed, it will decompose into cations and anions. So what are cations? The positively charged ions of the electrolyte are called as cations, and these cations, because they are positively charged, they will always move towards the cathode. Why towards the cathode? Because cathode is connected to the negative terminal, and this negative terminal will always attract positive charges, and cations are nothing but positive charges. So always cations will be attracted towards cathode. Okay. Now what are anions? Anions are negatively charged ions of the electrolyte. So these anions, they will move towards the anode. Obviously they should move towards the anode because anions are negatively charged particles, negatively charged ions. So negatively charged ions will always be attracted to the electrode which is connected to the positive terminal. Okay, so this anions will be attracted towards the anode. Okay, so cations and anions are what? That is clear to you now. Cations are positively charged ions, anions are negatively charged ions. Okay, cations will be moving towards the cathode, anions will be always moving towards the anode. Okay, now the next term in the series is electrolytic cell. Now what is this electrolytic cell? Now these electrolytic cells are the vessels or the container. Okay, they are the container in which the molten electrolyte is taken. Basically it's a glass bottle. It can be a glass bottle also, or it can be a tin ka box also. Okay, it can be anything. Okay, but basically it's a container. Okay, so in this container you will have to take that electrolyte in the molten state, right? And along with the electrodes dipped in the electrolyte, and this electrodes will be connected to the DC battery source. Okay, this entire combination, this entire assembly is known as an electrolytic cell. Okay? So basically electrolytic cell is an arrangement which you will have to make for carrying out electrolysis, and it will consist of a container like a glass bottle or a tin ka box, or a tin ka box, or whatever it is, and you will have electrolyte poured in it, you will have electrodes dipped in it, and you will have this DC source of electric current applied to it. Okay, so that is an electrolytic cell. Okay, so so far we have now slowly getting introduced to what is electrolysis, what are the terms connected to electrolysis. Now let us try to understand why only molten state or aqueous solution state is needed. Okay, see, I told you this electrolyte has to be in a molten state or it should be in the aqueous state. Okay, that is aqueous solution state. Now why this particular condition is necessary? The reason is electrolytes are ionic compounds. In solid state, these ions are not free, okay, to move, right? In molten state, the ions will break up and this ionic compound between them, these ions break up the ionic compound between them and are free to move. So when you melt a ionic compound, when you try to melt a ionic compound, what will happen? The ionic bonds which are connecting the two ions, okay, that will be broken, and after the bond is broken, these ions, okay, will be able to move freely, which we very much need. So to make it move freely, to make the ions move freely, this ionic compound has to be in the molten state. Now if it is not possible to bring it in the molten state, another option is you can dissolve this ionic compound into water. Now when you dissolve this ionic compound into water, now why water? Because water is a universal solvent for any ionic compound. Okay, so I mentioned here water being a universal solvent for ionic compounds. So most of the ionic compounds will nicely dissolve in water, and when the ionic compound dissolves in water, what will happen? Automatically the ions will be separated out. Okay, so the ionic bond will again be broken and it will be separated out, and the two ions will now be again able to move because they are free. Okay, free to move. So this is the reason why the molten state or the aqueous solution state of the electrolyte is very, very important. Okay, you cannot carry out electrolysis of any electrolyte in the solid form or in the compound form. Okay, now what's the difference between molten state and aqueous state? Now when the ionic compound is taken in a molten state or in the aqueous state, there is one particular thing that is happening, okay, which is slightly different in both. See, the reason for melting this ionic compound or dissolving the ionic compound in water is to make the ions be ready for moving. Okay, so we should get ions, okay, free ions. That's the reason we do this. Okay, but then what is the difference? The difference is what, in the molten state only the ions of the electrolytes are obtained. So when you are melting a particular electrolyte, then you will get the ions of that electrolyte only. But if you are dissolving that ion, that ionic compound in water, what will happen? The water will also be ionized, or water will also be splitting into its ion, that is hydrogen ion and OH ion. Okay, so this hydrogen ion and OH ion will also be obtained along with the ions of the electrolyte. So in the aqueous solution you will be getting more number of ions, and uh, in the molten state you will be getting only the ions of the electrolyte. Is that clear? So let us now try to understand the important concept of electrolysis. Now what is the important concept of electrolysis that we are going to start? Okay. The first point is ionic compounds give cations and anions. Fine. So any ionic compound on passing current through it, okay, in the molten state will be decomposed into anions and cations. So obviously any ionic compound is going to give you cations and anions. Fine. Example is NaCl. It's an ionic compound. On melting it, what will happen? It will create sodium ion and chloride ion. Okay, so these are the ions with the positive and the negative charge on it respectively. So sodium will carry positive charge, chloride ion will carry negative charge. Copper sulfate, again it's an example of an electrolyte, and when this electrolyte is decomposed it will result into copper ions and sulfate ions. Okay, copper ions will have two positive charge, sulfate ions will have two negative charge. Now sulfate is not an ion, you cannot call it ion technically, it's a radical. Okay, radical is nothing but a combination of two or different type of atoms, forming a group of atoms which will be still carrying some charge. Okay, so SO4 is a combination of 1 sulfur and 4 oxygen atom coming together, and this group of SO4 is carrying a charge of 2 negative. Okay, so this is a radical. H2O, again it's an ionic compound, and it is going to give you hydrogen ion and hydroxide ion. Hydrogen ion will carry a positive charge, hydroxide ion will carry a negative charge. So these are the three examples I have given you of any ionic compound giving you cation and anions. Okay, now second point, first point is done. Second point is, in molten state you get the ions of the electrolyte only. Now this I have mentioned you just now. Okay, that what is the difference between the molten state and the aqueous solution state. So in the molten state, what happens, the ions that you get are of the electrolyte only, because there's no solution, there's no water involved in that. Okay, so suppose you take NaCl, the ionic compound, and if you happen to melt it, okay, so if you take it in molten state, what will happen, this NaCl will give you sodium ion and chloride ion. So you will be getting sodium and chloride ion only. These ions are of the electrolyte only. Okay. But if it is in aqueous solution, if this electrolyte NaCl is in aqueous solution, you will get the ions of electrolyte. Of course, sodium and chloride ions you will get. But along with these two ions, you will also get the ions of water, that is hydrogen ion and OH ion. So in the aqueous solution, when you take an electrolyte, you will be getting more number of ions and you will be getting more number of cations and anions. In the case of NaCl solution, okay, aqueous solution, you will get sodium ion, you will get chloride ion, okay, which are the ions of the electrolyte NaCl, plus you will get hydrogen ion and hydroxide ion, which are the ions of the water. Okay, so you are getting 4 different ions over here. In a molten state, you get only 2 ions of that respective electrolyte. Okay, so that's the second point that you should understand properly. Now coming to the third point, and the third point says that anions are always attracted towards the anode and the cations are always attracted towards the cathode. Okay, anions are attracted towards the anode, I'm sorry, and cations are always attracted towards the cathode. Okay, remember this, anion starts with a, anode starts with a A. So anions and anode, they will be attracted towards each other. Cations start with a C, cathode starts with a C, same. So cations will be attracted towards the cathode. Is that clear? So this is the way you can remember that anions are always attracted towards the anode, cations are always attracted towards the cathode. I'm sorry, anions are always attracted towards the anode and cations are always attracted towards the cathode. Okay, anions anode, cations cathode. Is that clear? Fine. So now suppose you have a chloride ion. Now chloride ion is having a negative charge, so it is an anion. Okay, now you know that negative charge will always be going towards the anode, because anode is connected to the positive terminal, so there will be always attraction between the positive and the negative. So chloride ions will always move towards the anode. Fine. Sodium ion, because sodium ion is having a positive charge, it is known as a cation. So the sodium ion is being a cation, it will always be attracted towards the cathode. Why? Because sodium is having a sodium ion is having a positive charge on it, and cathode is connected to the negative terminal. So again the negative and the positive is going to attract each other. Same way OH ion is an anion because it is having a negative charge and it will be attracted towards the anode, and hydrogen ion being a cation, it will be attracted towards the cathode. Okay. So that was the third point that you should remember. The fourth point is, these are the important concepts of electrolysis. Okay, once the concepts are discussed and understood in a nice way, then we'll start studying electrolysis of certain electrolytes in a detailed way. Okay, now coming to the fourth point, if an electrolyte is in aqueous solution state, then many anions and cations are formed. Okay, this we have already discussed. But out of all these only one anion and one cation is going to reach the corresponding electrode. Now see, you have only two electrodes in electrolytic cell. You have only two electrodes, one anode and one cathode. And suppose in the electrolyte, if it is an aqueous solution, if the electrolyte is in a aqueous solution state, then apart from the ions of the electrolyte, you will also have the ions of water, that is hydrogen and hydroxide ion. So you will have two cations and two anions in that case, isn't it? You will have two cations and two anions in that case. So there will be four total ions in that case, okay? But out of these two anions, only one anion has to reach, okay? Only one anion has to reach, and only one anion will reach the anode, right? And out of these two cations, only one is going to reach the cathode. Out of the two cations, only one is going to reach the cathode. It's not that both are going to reach, okay? So out of this many anions, okay, whether there are two anions or three or four, okay, out of many anions, only one anion is supposed to go to the anode, and out of the cations, only one cation is supposed to go to the cathode, right? So that's the rule, okay? Only one has to go and reach the this thing, okay? uh, Second, cursor is not working. Yeah, that's working. So that's the fourth point, very important one, okay? So out of many anions, only one is going to reach, or one is supposed to reach the anode, and out of many cations, only one is supposed to reach the, now which one is going to reach the anode or the cathode, that we are going to see, okay? The fifth point is, there are certain rules for this. So for the anode, for the anions to reach anode and for the cations to reach cathode, there are certain rules. And what are these rules that you have to understand in a better way? So rule number one is, if it's between hydrogen ion and any other cation with a single positive charge, okay? So the charge, if you have suppose hydrogen ion from the water, and suppose you have a sodium ion from the NaCl electrolyte, okay? So you have two positive charges now with you, a hydrogen with a positive charge and a sodium with a positive charge, okay? So both are there. Now which is going to reach the anode, sorry, the cathode, okay? Now because both are positively charged, the both will be attracted towards the cathode. Cathode will attract both, but out of these two, only one is supposed to reach, okay? So there will be a competition between the two, and in this competition there will be only one winner, either hydrogen ion or sodium ion. So the rule says that when there is a competition between a hydrogen ion and any other ion like sodium, okay, then hydrogen is going to reach the cathode, okay, not sodium. Now there's a rule behind that. This rule is what that we can understand with the help of something called electrochemical series. So this particular point at which, when I told you that out of hydrogen and sodium is going to be the hydrogen ion which is going to reach the cathode, not the sodium ion. Suppose there was a hydrogen ion and a copper ion, okay, then the copper ion would have reached the cathode, okay, not the hydrogen ion. So here there is a doubt coming in your mind. There should be some ambiguity, like what is the reason or what is the rule? Why in this case hydrogen has to reach the cathode? Why in this case copper has to reach the cathode? Okay. So to understand this particular rule, you have to understand something called electrochemical series. Now this is electrochemical series. Now electrochemical series is a very deep topic, so you don't have to go very much deep into it. I'll just explain you how much we need right now. Okay, so we have to understand, out of hydrogen and some other positive ion, which one is going to win the race of reaching the cathode? That's the question. That's the biggest question. To answer that question only, we are going to study this electrochemical series. Now, what is this electrochemical series? The definition says that when elements are arranged in the increasing order of the standard electrode potential, it is called an electrochemical series. This is the definition. Now, according to this definition, if you see this table, you will see that this some elements, they are arranged here in this table. Okay. So if you see this table carefully, you can see this hydrogen element is kept in the center of the table, and there are certain elements which are placed below the hydrogen, and there are certain elements which are placed above the hydrogen. So can you see these are the elements which are placed above the hydrogen in the series, and these are the elements which are placed below the hydrogen in the series. Is that clear? Okay. Now the thing is what, this hydrogen has a standard electrode potential as 0. So standard electrode potential of hydrogen is 0. This helps in taking this as a reference. Okay, so hydrogen is taken as a reference. Now all the other elements, okay, all other you can say elements, okay, which are having this standard electron potential, okay, less than 0 will be placed above and greater than 0 will be placed below. This is how an electrochemical series is made. Okay, a hydrogen being the reference point, all these other elements, that is lead, iron, zinc, aluminium, magnesium, lithium, there are many more. These are few of them that has been shown in this series. There are many more missing in this. Okay, so lead, zinc, iron, aluminium, magnesium, lithium, these are the elements which come at a place higher to the hydrogen or above hydrogen, you can say. And you can see these elements, that is copper, silver, mercury, gold and fluorine. These are the elements which come below hydrogen. Okay, so there is something called above hydrogen, there is something called below hydrogen. Now this is very important, above hydrogen and below hydrogen. Fine. Okay, now if this particular arrangement, now this is the arrangement of the electrochemical series. So from bottom to top if you go, so if you go from fluorine to gold, from gold to mercury, from mercury to silver, silver to copper, if you go from bottom to top, okay, then from copper to hydrogen, hydrogen to lead, lead to iron, iron to zinc, zinc to aluminium, aluminium to magnesium, magnesium to lithium. So when you go this way from bottom to top, okay, what is happening, that I have written here. So the ease with which the electrons are lost, okay, uh, increases from bottom to top. So if you go from bottom to top, that is from fluorine to lithium, if you go along this line in this direction, okay, what these elements are going to indicate is the ease with which the electrons are lost is increasing. So the meaning of this is, this lead is taken, suppose you take lead, okay, and suppose you take mercury. So lead is higher in the series, okay, it is above and mercury is below. Okay, so if you see carefully, this lead is higher at a higher place and mercury is at a lower place. So the element which is at a higher place, okay, will be more easily losing electron compared to the element which is at the lower place. So lead will be losing electrons very easily compared to mercury. For that matter, any element on the top will be losing electron more easily compared to the element below it. That clear? So this is the meaning of electrochemical series. Now the same electrochemical series, if I take it in a horizontal line form, okay, like a number line in mathematics, so you can see this 0. Okay, so this 0 is nothing but this 0, the EMF voltage value of the hydrogen, that is 0. Then can you see this 1, 2, -1, -2, -3, these are the values of this electron potential, that is standard electron potential. Okay, so some of the values are positive, some of the values are negative. So positive values are written on the right hand side of 0 and positive values are negative values are written on the left hand side, like in the number line we do. And this is hydrogen, which is having 0 standard electron potential. Then can you see this copper, gold, mercury, all these are having more than 0. Okay, in the positive direction they are having values more than 0. So I have taken this copper, gold, mercury, copper, silver, mercury, gold, fluorine on this side. Okay, and these are taken on the other side. Okay, that is lead, iron, zinc, aluminum. These are decreasing. These are less than zero. Okay, so these I am taking on this side. So this way also you can show the electrochemical series. Okay, now here instead of telling below hydrogen, you can say on the right of hydrogen, and these are on the left of hydrogen. So on the right of hydrogen you will find these elements, okay, which will be having which will not lose electron that easily, and these are the elements which are going to lose electrons more easily. Okay, so elements on the left of this line, that is these elements, can you see these elements? Okay, on the left of this line lose electrons very easily, more easily. So these are the ones which are going to lose electron very easily, and these are the ones which are on the right. Okay, so compared to those on the right, so these elements on the right, you know, they are not going to lose electron easily. Okay, they will lose electron, but they will require more energy to lose that electron, and that is why the electrode potential is more. That clear? It is positive, right? So this is the meaning of electrochemical series. Now what will this electrochemical series will help you, that let me tell you. So now that you know what is electrochemical series, now you can understand this one point. In an electrochemical series, elements are arranged in the order of how easily they lose electrons. Okay, the order is from bottom to top of the series. Example, if you take silver, and if you take in comparison to mercury and gold, the silver loses electrons more easily in comparison to mercury and gold. Why? Because silver is at a uh, higher place compared to mercury and gold. Can you see here? The silver is over here. You see this? This is silver. It is above mercury and gold. Can you see these three? So silver is above mercury and gold. So it is indicating that silver is going to lose electron more easily compared to gold and mercury. Same way, zinc is going to lose electron more easily compared to iron and lead. If you see this zinc, iron and lead, let me show you that. Can you see this is zinc? Okay, this is iron and this is lead. Can you see these three? So in this three, the zinc is on the top. So zinc is going to lose electron very easily compared to iron and lead, because zinc is occupying the place higher in the series. Okay, so that is how you have to interpret the electrochemical series. So in the electrochemical series, the elements which are higher placed, okay, which are placed at a higher position, they are the ones which are going to lose electron very easily. That is one concept you should understand very well. Again, if you happen to see these electrodes, you know, if you take electrodes, now these are the things which are much more in detail. I don't suppose these are there in your IGCSE curriculum right now. It is of no use of going into this. So I don't think I will go into this, because unnecessarily it will confuse you more. So just remember that in electrochemical series you have certain elements arranged in such a way that certain elements are above hydrogen, placed above hydrogen in the series, and certain elements are placed below hydrogen in the series. Now what happens whenever there is a competition between hydrogen and some other positive ion? Okay, then what happens? It is always the one which is at a higher place, okay, that is going to win the race of reaching the cathode. Okay, so that you remember. So that is why, you know, in sodium, I told you here I give you an example. Okay, can you see here? Here there are here I have given you two examples. Between sodium and hydrogen, it is always the sodium which is not going to reach the cathode. It is hydrogen which is going to reach the cathode. Now why hydrogen? Because if you see sodium and hydrogen, okay, sodium will be at a place which is above hydrogen. Now sodium, if you want to see the place of sodium, now it is not given in this particular table, but it is somewhere around here in place of lithium. It is having a negative value. Okay, so it will definitely be above the hydrogen. Okay, So all the elements which are above hydrogen, okay, they are going to lose that race of reaching the cathode. So nitrogen being above hydrogen, it is going to lose the race. So hydrogen is going to reach the cathode. But if you see the competition between hydrogen and copper, this copper is below the hydrogen atom. Okay, so copper being below the hydrogen atom, what will happen is this copper is going to win the race. Okay, between hydrogen and sodium, the hydrogen was below the sodium, that is why hydrogen reached the cathode. Between hydrogen and copper, the copper is below. In the series, copper is below the hydrogen, so copper is going to win the race. So when there is between the competition between copper and hydrogen, it will be copper which will be going to the cathode and not the hydrogen. So this is one point that you should remember as a rule number 5, that which is going to reach the cathode. There's one more rule in this connection. If this is for the cations, okay, but suppose there's a competition between anions, okay, then anions may, it is always the ion which is more in concentration, available more in number, that is going to reach the anode. Okay, so in anions it is this rule, and in cations, that is negative ions, the rule is the one which is present in higher concentration, okay, will win the race in reaching the anode. Okay, so with all these things as a background, okay, next is we are going to study electrolysis, okay, with the help of certain examples. And I don't think all these things I want to explain it, although I have put it on this notes of mine, but later on I thought that is not relevant to your syllabus right now. Maybe in the higher classes, maybe when you go for IB, okay, so in the 11th 12th classes in IB, in chemistry you will have all these things, so right now you don't have to bother about that. Okay, so that's all about this today's session in chemistry. I have just made you introductory concept of electrolysis, electrochemistry, and now in the next session, in the next video, I'm going to give you some examples of electrolysis and explain you what is happening there in electrolysis of each and every example. Okay, so that's all for today in this today's session, and that's all that I wanted to talk about. That's the theory aspect of this electrolysis. So if you happen to like this video of mine, please subscribe my channel and press the bell button, and that's all for today. So see you in the next video very soon. Bye.